What is the hardest concept to master in C programming? If you ask this question to anyone, the unanimous answer will be pointers. In this video, we are going to learn a very simple concept to make pointers easy and interesting. First of all, we should understand what happens in the machine when a variable is declared. Consider that I have a machine with 100 bytes of memory. So, each byte is addressed from 0 to 99. In this machine, I am executing this simple C program. The first line in this program tells the machine to declare a variable and initialize it with value 10. In a typical machine, size of an integer is 4 bytes. So the machine will allocate 4 bytes for the variable A. Let's say it allocates byte 20, 21, 22 and 23 and stores 10 inside it. As the value 10 requires just 1 byte to be stored, it is stored in the least significant byte of the allocated memory. In our case, it is byte 23. Which among the 4 bytes is least significant one is defined by the NDNS of the machine. We will see about it in detail in another video. The second instruction of the program says print A in the console. Here comes the problem. How does the machine know which location in the memory is A? The machine executes code one instruction at a time. It cannot go back and forth to figure out what is what. To solve this problem, a new data structure is introduced. It is called symbol table. As the name suggests, it is a table with 3 columns. The columns are name, type and address. Now let's see what happens while executing the same program. Additionally, we have a symbol table this time. Upon execution of the first line, 4 bytes 20, 21, 22 and 23 are allocated in memory and 10 is stored in that. Additionally, an entry in the symbol table is created as follows. Name of the symbol is A, type is integer and the address is 20. Though 4 bytes of memory is allocated, only the address of the first byte is stored in the symbol table. Upon execution of the second line, when the machine is instructed to print A, it looks for the symbol A in the symbol table. The entry says the address is 20. But how does the machine know it has to read subsequent 3 bytes as well? That's why we have type column in the symbol table. As integer is 4 bytes, the machine reads 4 bytes from the address 20 and prints the value to the console. How does understanding this concept is going to help us with pointers? First, we should learn following 2 notations. Whenever you see an ampersand followed by a variable, you should always read it as address of. Similarly, whenever you encounter an asterisk followed by a variable, it should be read as value at. Let's take this simple C program depicting usage of a pointer. The first line declares variable A and initializes it with value 10. As we know, 4 bytes of memory is allocated and value 10 is stored in that memory. And a symbol table entry is created too. The second instruction declares an integer pointer and initializes that with address of A. Recollect the notation here. As pointers are 4 bytes in size, 4 bytes of memory is allocated in space from byte 80 to byte 83 and an entry for the variable is created in symbol table. To initialize the variable, address of A is required. So it is searched in the symbol table. As address of A is 20, it is stored in memory 83. The third instruction says print value at PTR. PTR is 20, so value at 20 is nothing but 10. The type integer pointer says that when you read address 20, subsequent 3 bytes also need to be read together. Symbol table is used only during compilation but not program execution. During program execution, all the variables including pointers are converted to corresponding addresses and registers, so there is no need of a symbol table. But including a symbol table while dry running and debugging a code will give you an upper edge and save a lot of time. This abstract concept is not just specific to C programming, you can apply it for any programming language. Thanks for watching this video. Please subscribe to our channel for interesting concepts like this.